Okay, so let's go and do that. So first, I'm going to create an interface. How to create interface? So let me create interface. I'm going to Oops Programs package. See here, you have an option interface. Like you have option class, right? Same way, interface also one template, same as a class. And naming conventions also same as a class. But class is different, interface is different. Both are different. Two different entities. So don't confuse, both are same, okay? Both are entirely different. So I'm just creating one shape interface. Under this interface, what are all things you can declare? I mentioned already, we can declare constants. We can declare abstract methods. We can declare default methods. We can declare static methods. So that's what I'm going to show all of them. So I'm just taking from here. So these are the constant. How to declare constants? I already told you. Public static final keywords will add for the constant. This is the constant. Constants you will write in capitals. Constants you will write in the capitals. See, even if you don't add public static final, this will internally add these three keywords. This will add internally to that one. And see abstract methods. I just created a void draw method. So this is the void method, but internally it will add public abstract void draw. This is the full form. Explicitly, you don't need to write public and abstract. So everything is abstract method here in the interface. Next, double get area. This is a return type. That means this method is returning a double data. This method is returning a double data. Getter methods. See, internally it will add public abstract double get area. And default method. See, default method starts with a default keyword, but this also public will add automatically here. Default before. And here also public by default, this one. All the methods and constants are public by default. You cannot reduce. See, if I reduce, it will throw error. See, it will throw error. So illegal modifier for the interface method run, only public, private, abstract, default, static, strict FP are permitted. See, protected is not applicable. Okay. So that's the thing. Even private also you can add if you want, but that is permissible from Java 9 onwards. So we are Java 11 you are using, that's why it is acceptable. Okay. So that's the interface, has abstract methods, constants, default methods, static methods I created. Now default methods you already implemented. Static methods also we implemented. But abstract methods we didn't implement. We didn't define them. There is no definition what this method has to do. I haven't defined. So I'm going to define this in my different shape classes. So what are different shape classes? What are different shape classes? Hmm? What are different shapes, Andy?
Circle or rectangle.
Rectangle, circle, right?
Yes,
So let's create a circle class. So circle class, I'm creating a class circle. So I'm going to implement, I'll just implement if I want, okay, I'll just implement. Okay, so I don't want, okay, this is the different packages. So here I'm going to create. So circle class. So I'm not taking method because I'll implement first my interface. So what I need to, what keyword I need to write to implement my interface? Implements. The interface name. See, now it is asking, okay. The type circle must implement the inherited abstract methods shape. So all the methods of shape must implement in the circle class, it is saying. So add unimplemented methods, automatically it is asking add. See, all the methods you are overriding. This is the method overriding also you are getting. So, but circle, if you want to get area, what you need? What property you need for circle? Hmm? What property you need? To get the calculation of area, what property you need, Andy? This is not Java, this is not anything, just is a basics of your education.
So draws. Draws.
What?
Draws.
How can you calculate area, boss, for the circle?
Pi r square, sir.
Then what you need? What you need to get that pi r square? Okay, but where is that r? What is that r?
Radius.
Radius, right? Radius, right? To tell that also, this is this Java, Andy? Huh? Is this Java?
Yes.
Then, so how can you give this value? I don't want a hard code. How can you give the particular instance variable value?
Using setters and vector. Setter methods, sir.
Okay, one is header. What is the other way?
Using constructors. Through constructors, sir.
Through constructor. So I'm creating a parameterized constructor. So how can you create a constructor? Class name and constructor name is same. Double radius. This dot radius equal to radius. So I'm not going to implement much because these are all very basics. So I'll just write. So basically, I just implemented pi r square. See, where you can get pi in the math class, this pi is defined. Already this is the constant. How can you call particular class constant? Class name dot constant radius, pi r square. Same perimeter, what is the perimeter? 2 pi r. So 2 multiplied by pi value. So math dot pi r. So r. So this is the how to implement this one class. And another class I'm going to use. So maybe I can use square. Square class. Same way I'm implementing square class also. And another one triangle. So rectangle. So another one rectangle. So like this, my interface is implemented in 3 classes. See let me show you one by one. So this is the one. Square implements shape. So for a square, we need a side, right? So that side well I'm giving through parameterized constructor. So when you're creating object for this class, you have to create object because these are all non-static methods. So when you create an object, pass this parameter value. That means you can give your own input value. So that is this, and then draw method regarding to the square you implement. So get area method side by side. The same methods we are developing differently. That is what the power of interface. So interface will give you a provision. So you declare some methods which are common to all different people. Those methods they can implement their own way, and then you can call them with that interface and the right hand side that class object. Then you will get this logic only. If you create object for square class, you will get this logic only for this get area. If you create object for this class and you call this method, you will get this logic only, not circle class logic. So which class object you create, that class logic you will get it. That's called runtime polymorphism concept. So and also you are overriding the methods. The overridden methods will be called, right? So with the child class object, then the pointing to parent class reference variable. So this is the square, and another one is so rectangle. So rectangle, what are the parameters you need? Two instance variables we are taken, length and breadth. So and length and breadth I am passing through constructor, and then override the methods. So area, how can you get? Length multiplied by breadth. And get parameters. So perimeter, how can you get? 2 multiplied by length plus breadth. So this is the perimeter, how you can get it. So this is how we implemented same interface in multiple classes. The same thing happened in WebDriver also. WebDriver is one interface. That interface is implemented in multiple classes. Like each browser, one class is there. That browser classes, this WebDriver is implemented. So that's a replica I am showing here. How WebDriver is implemented. Already WebDriver implementation done. You don't need to implement again. They already done the implementation. You just, okay, once the implementation is done, what is the next step? That I'm going to show you now. So what we need to do is, so yesterday I told you some steps. So the interface we created, implementation is done in the classes. Then what is the next step? You need to consume them, right? You need to use these methods. So how to use them? So that's what I'm going to show you now. So how to consume those methods. So let's call that, I'll just take one implement, call interface methods. So I'm just, created a new class again. See that. So it's a normal class. In this class, first step, interface reference variable equal to new implementing class. Which class you implemented this interface methods, that class you create object. That's what I did. See, shape is the interface. See, I'm following this formula. Shape reference variable equal to new square 3.5. So then you will get a square logic only here. So that's why, so yes dot object reference dot non-static method. So return type method, how you can call data type, variable name, object reference dot return type method. So that's what I covered this in the methods. I'm calling again. So data type means double. This method returns a double data. That's why double. So variable name equal to object reference dot get area method. So then you can print the return type method directly in the print statement. So object reference dot get parameter method. And then, so you can call the run method. Run method already we developed. This is the default method. How can you call default methods? With object reference you can call. So how can you call static methods? So interface name dot static method. How can you call constants? Interface name dot constant. So constants, generally static stuff. This is the static things. So this is the return type. I'm just calling return type of the method. Variable name equal to interface name dot constant. So how can you call? So constant of interface name dot constant. So that's it. And you can see now, if you execute this, only you will get a square logic. Suppose you want to execute circle logic you want. So you create object for circle class. Then you will get a circle class logic. See, all the circle class logic it will execute. If you want a rectangle, so you enable that, create object for rectangle. So now you will get a rectangle logic. See, this is the rectangle logic. Which class you create object, that class logic it will execute for you. Okay. So that's it. And we'll come back and I'll show you how to call in another packages. Okay. So join back.